So hi everyone, my name is Elie Bursztein, and I'm going to present you today with Jean-Michel and Mathieu, which is here OWADE, which is a cloud-based forensic tool. Ivan couldn't join us today. So the premise of this talk is the world is moving to the cloud. I see a lot of people here in this room using their laptop or iPad, and all of you have some sort of data in the cloud. For instance, we know that 2.7 million photos are uploaded to Facebook every 20 minutes, and about 100 million new files are saved on Dropbox every day. So a lot of data is flowing from computer to the cloud, and people move almost everything which has value for forensic to the cloud, including emails, which are moving to webmail, contacts, which are moving to social networks, like LinkedIn, and of course photos which are uploaded to a photo website such as Facebook or Flickr and so forth. And it has a huge impact on everyone who do forensics today, as there is more data, but this data also became harder to reach because you can't just take down the files and recover them. They are not in the hard drive by itself. So what we need is we need to have a change in how we deal forensic, and we need to move to what I would say reinvent the field and do cloud forensic. But what is cloud forensic exactly? What we mean by cloud forensic is the ability from the hard drive to recover the necessary information to get the online data and use them in our forensic case. Once again, I'm not going to discuss whether it's legal or not. I'm just telling you what is possible from a technical point of view, and I'll let you guys figure out with the lawyer whether you can do it or not. Let me give you an example of why it's hard. Let's assume I want to know who is someone on Facebook. I get a hard drive and I know this person is a user of Facebook. Now I need to know who he is. To get the Facebook credentials, they are probably stored in IE password manager. The IE password manager is encrypted with DP API. If I want to decrypt that, I have to decrypt the DP API master key. To decrypt the DPI master key, I have to actually decrypt the Windows password. And to decrypt the Windows password, I have to be able to decrypt the SAM. If we sum up all of this, we actually need to bypass 4 layers of encryptions to get to the point where I get my Facebook credential from my hard drive. And this is my promise to you. This is what the talk is about how we bypass layers of encryption which are stuck on a Windows disk to get the data you want, which are user history and credential for the web. And I'm going to walk you through every step we need to do that. And we also have written a tool, which is open source, and you will be able to get after the demo, after the talk, we're going to make it public, which is called OWADE, which stands for Offline Windows Analysis and Data Extraction Tool. It's an open source tool which is written in Python and work on Linux. This tool is able to decrypt DP API secret, which are the data encrypted with the Windows API using OpenSSL only. It's fully open source. And we are also able to recover browser history and credential for all the major 4. And we also are able to recover instant messaging credentials such as Skype's one. And finally, we're also able to recover Wi-Fi data, such as the access, the WPA key from the hard drive. So OWADE looks like this. It's basically the interface is a web interface, and you can click on it, and I'm going to show you various screenshots. And maybe at the end we will be able to do a demo, but we have to switch laptops, so maybe it will work, maybe not. In any case, you can download it. So how OWADE works? What is the big picture for that? OWADE works by first you take a disk, and then we're going to do an image of this disk, as we're not allowed to tamper with evidence. And when we have this disk image, we're going to extract the registry from this disk and also the files. When we have that, we're going to go deeper into the hierarchy and do more advanced analysis. The first one being we need to recover Windows credential. When we have the Windows credential, we are able to actually extract also the Wi-Fi data, such as the WPA key, and we also extract a bunch of hardware information, as some software, like Google Talk, actually use some of the hardware information to encrypt the data. When we have that, we move to another an upper layer, which is the application layer, where we're going to recover Internet Explorer, Chrome, Firefox, Safari, instant messaging, and Skype credential. And we're going to walk you through all the process to do that. And when you have that, we also have some probes to go to online services and extract the data with the credential we have. That's what OWADE is doing. So let's see how we're going to play, how this talk is going to be, the rest of the talk is. So first, we're going to give you a very quick file forensic refresher to see how we get from the disk to the registry. Then I'm going to tell you about the Windows crypto system for those who are not familiar with it, how it works, how DP API works, so you get the idea how we can decrypt that. Then we're going to do how you can actually extract Wi-Fi data and how you used to be able to do geolocalization with that until Microsoft patched it, I think, Sunday morning. So, and then how you recover browser data, like, such as history and credentials such as login and password. Then I'm going to discuss with you what are the algorithms which are used in instant messaging software. And finally, we're going to discuss a little bit how you can acquire directly cloud service data. And finally, if it works, as I said, we're going to show you a real live demo of OWADE. And if it doesn't work, then you can download yourself the code and test it. Fail-based forensic. So there is different kind of hard drive you can get. The standard one is you see the laptop, and all you have to do is plug the disk, and then you recover all the file. And there is some file in the trash, but there is an utility for that, which is undelete, and we recover them. If the file are deleted, we have to do file carving, which basically look sector by sector on your hard drive and try to look for fingerprint of each file. This is standard techniques. And if the disk is whipped, my only advice for you is go ask the NSA how they do it. I have no idea. So the Windows registry, they are basically on the disk. They are basically a DAT file which are located into the Windows directory. And they contain a ton of information, such as the hardware information, software installed with the version and serial number, and they also have the Windows credentials which are encrypted. If you look at how OWADE do that, it's actually going to display you a bunch of information. For instance, here you can see that the disk from which we extracted the information is actually a Core i7, and you have the frequency of the processors, and we also have the ability to know every type of USB token and dongle you have ever plugged to the computer. So if you want to know if someone actually put a USB key on your computer, you can actually know that from the registry. So that's the registry information. Let's move on to the Windows crypto ecosystem. So the crypto ecosystem by Microsoft is used by a lot of Microsoft products, of course, but also third-party software such as Google products and Apple products. So you need to be able to deal with Microsoft encryption if you want to acquire high-level data. So the big picture is the following. At the bottom, you have the crypto API, which do all the encryptions by itself. And you have the security account manager, which basically store all the user password. It's like the keychain in Apple. And then you have, sort of. And then you have DP API, which is basically a transparent API for a program to encrypt and decrypt data, which is going to be tied to the user password. And on top of that, you have something else on a third layer, which is the credential manager, which is an API which deals with encryptions and also storage. So when you use a credential manager, Windows encrypts it and stores it for you, and you just ask to retrieve it. It's just like treat it as a DB where you don't know what the DB is, but it's actually going to be encrypted for you. The crypto Windows API do basic cryptography, or every basic block you can imagine, from cipher encryption, TRIPS, AES, hash functions, SHA-1 and so forth, and public key crypto. We're not really concerned in this talk with public key crypto. We're not concerned directly actually with this crypto API, because in OWADE we use OpenSSL, which actually do exactly the same except it's open source and it's run on Linux, of course. So how the passwords are stored, how the Windows passwords are stored on Windows? Well, they are stored in what is called the SAM, the Security Account Managers, and it's located into the registry, and it's encrypted with the syskey. So the syskey was an attempt from Microsoft to actually prevent you to decrypt the password offline. So they offer the option to put the syskey on a USB key. I never found anyone whoever put it on a USB key, but in theory you can. There is the option somewhere. I have no idea how to put this pop-up actually in Windows, but in theory you can. And when you don't do it, well, the key is on the disk. So what OWADE is doing is look through the registry and is going to find the sys key and decrypt the stamp for you, and then we have the hash of the password. So that's why I say encrypted, because it's unlikely that anyone ever use it. Maybe it's possible, just I never encounter anyone with this. And the passwords are not stored in clear. They are stored in a hash with the hash functions. And in practice, Windows use two kinds of hash functions. So the first one is called the landman or LN hash function, which has been introduced in NT and is actually considered as a weak hash function. I'm going to be discussing this in the next slide. And starting XP, they have the NTLM, which has become the default function for Windows 7. And NTLM and LM hashes are only disabled by default starting Windows 7, which means that we can actually exploit the weakness in LM hashes up to Vista. So one thing to note is passwords are not sorted, meaning that we don't have a random string in front of them, which means that we can use pre-computed attack as well, also known as rainbow table on Windows password. Let me give you an overview why LM hash are weak. First, they decided for a very odd reason that we're not going to use lowercase. So when you actually use LM hash before hashing, Windows put your password in uppercase. So it doesn't matter if you type lowercase or uppercase, it's actually the same. And then for another odd reason that I can't explain myself, they decided that instead of storing the password in one hash, they split it in two hashes. The first hash is the first 7 character. The second one is the 7th part of the character. So now all we have to do is crack a 7 character long hash. So it turned out that the complexity of it, so you have an example in blue. If your password is my password, first it's put into uppercase, and then you're going to have 2 hashes which are going to be concatenated. So in this case, the key space, the full key space of LM hashes are 69 to the power of 7, which is something we can actually pre-compute completely ahead of time. And this is rainbow table. So rainbow table are basically a trade-off between memory and time. So you pre-compute all the passwords, but instead of storing them directly on the disk, you store them with a little bit of computation. It's called chain. The basic idea is it's slow. It increases the speed of recovery of the password, but you still have to do some little computations, and it doesn't take a lot of space. The LM hashes in rainbow table is about 64 gigabytes of data, which is absolutely nothing in today. I mean, with the price of a hard drive today, not an issue to store that. And rainbow table for all the LM hashes, all of them, which means instant recovery or almost instant recovery, are available for download from multiple websites. So LM hashes are not, if you are using XP, our success rate to recover your password is close to 100%. That's how it is. So how OWADE works. OWADE first extracts the username and the password hash, and then it's going to test if we have the LM hash. If the LM hash is there, then we're fine. We're going to try to use John the Ripper, and we plan to have a rainbow table module to just crack it and have the password in uppercase. And then we're going to use the NTLM hash, which is case sensitive, to actually figure out what is the case of your password, and then we're good to go. If we only have NTLM, well, we're going to try rainbow table up to 7 characters because some of them are available. And we're going to use John the Ripper, which is a password cracker, which is the most well-known, I think, open source password cracker, to try to go after that and try dictionary and so forth, and hopefully we might be able to recover your password. Once this is done, OWADE is going to show you something like this, which is the name of the user, the hash, the 2 hash you can have, and then the password if we can get it. When you see unknown is basically when we are not successful at recovering it. And if you are following me so far, what I said is if you have 7, which is not currently supported in the release of OWADE, but if you are on Windows 7, well, sometimes we can't crack the password if the password is strong. And, well, sometimes if the password is too strong, well, I must say we can't recover it. But in a way, it's not that a big deal, because there is other way. We don't really need the password to extract your application data. And that's how DPAPI works and how it stores its key, which makes this possible. I'm going to give you, I'm going to explain this after I explain how DPAPI works. So, the DPAPI, also known as Data Protection API, is the API released by Microsoft with the idea in mind that if you store high-level passwords, they should be tied to your Windows password. So the same user on the same computer or people who are able to steal your laptop are not able to extract your password directly without doing some work. It's a black box API. So basically, the Microsoft documentation is very succinct. It's going to say, here's a function to encrypt, and you get a blob. Here's a function to decrypt. You give me a blob, I give you the key. The main point is DPAPI sole goal is to tie your encryption data with the user password. How it works in practice is it's a derivation scheme. What we need is actually the SHA-1 of the password. We don't need the password itself. We need the SHA-1 of the password, which is going to be used to compute a pre-key. And this pre-key are going to be used to decrypt the master key, which it's a big chunk of 512 bits of entropy that you use to decrypt the blob key, which is going to contain your data. And then from there, we get the content of the blob, which is usually the credential you are looking for. And of course, it's applied to multiple blob keys. Briefly, the structure of a data blob look like this. You have the cipher you are going to use. It is DDS on XP. It is AS on 7. You have also in orange, as you can see, you have obviously your data encrypted, and you also have the salt. The data is salted, so if you have two blobs which are the same, we won't be able to tell because we have a salt. And that's how a blob is. And you have a ton of information on this. If you want to really understand how DPAPI works, we actually made a presentation about that about a year ago. So you have all the nifty details there. But the basic idea is you have this structure, and the master key contain as well a salt, a MAC algorithm for integrity purposes, and a cipher text, an encrypted block, which is encrypted with a cipher algorithm. Again, DDS for XP and 7 and AES for Windows 7. So, how does it work in practice? Let's see how we can actually decrypt a DPAPI blob step by step. So we recover the DPAPI blob. From there, we're going to look for the master GUID because there is multiple master key. You have one which is generated every 3 months by Windows, so we need to know which one we need to use. And then from this master key, as I said, we're going to be able to compute the pre-key by using the SHA-1 of the user password. And from there, we're able to decrypt the master key. When we have the master key, to get the master key, we need to know which cipher we need to use and the salt which we extract from the master key file. Then we're going to try to decrypt the blob key. To decrypt the blob key, you need the salt and the initialization vector, which is in the DPAPI blob. But, and there is a big but here, at least for forensic, is software can add an extra entropy here. And this entropy is required to decrypt the blob. And that's really what makes reverse of all the application hard, is every software we know, or at least every software which has reasonable security, have a different and unique way to compute this extra entropy. And so every time you want to add a new decryption algorithm, let's say for Firefox or for for Safari, Chrome, or let's say, then you have to actually look into their derivation scheme, and you have to figure out how they derive this extra entropy. So back to what I said before, what happens if we can't crack the Windows password? Well, as I said, we don't really need the password. All we need is the SHA-1 of the password. It turns out that if you have a laptop, it's stored into the Hibernate file. When you put your computer on sleep, the password is actually stored in the Hibernate file. And thanks to Matthew's switch tool, Moonsol, you can actually look into the Hibernate file and extract from it the SHA-1. We have an heuristic for that. And then we just use that. So we don't have your password, but we can still decrypt your Internet Explorer or your Safari content. Main point, as I said, is the software additional entropy view it as a key. That's a key which actually prevents us to decrypt all the password in a generic fashion. We need to figure out how this key works. and it usually requires a lot of time. Some people do the smart thing, which is they try to tie the software encryption to the machine by looking at some hardware data, like the volume key, to get all the netbus name. So that's why we have to do all the registry analysis beforehand, so we can know which information to supply to this derivation scheme that I'm going to present in a few slides. On top of DP-API, we have the credential manager, which actually do encryptions with DP-API and then store it into a file which is called the cred store. It's used by Windows, Live Messenger, remote desktop, and it also contains all your network passwords. There is three kinds of type of credential which are stored into the cred store. So the first one being generic password, which are encrypted with DP-API inside the DP-API. So you have to do 2 rounds of DP-API to decrypt them, and you use a fixed string as additional entropy. So we know what it is. We just have to figure out where it was, and you use that. It's used by Live Messenger, which is the IM client from Microsoft. The domain password are just stored plainly into the cred store, and it's used, for instance, for NetBIOS password. Domain certificate is only used for Active Directory, and they basically only store the hash of the certificate. And the other one, which is very interesting for us, is the domain visible password, which use DP-API plus another fixed string that you have to pull out from the registry. And it's used for remote access password and also for the .NET passport, which was used by Microsoft. How we deal with Wi-Fi data. So the information that Windows store for every access point you ever access are the MAC address of it, the BSSID, its key, which is encrypted with DP-API, so you can't read it directly, and the last time you access it. In Windows XP, it's stored, all of this is stored in the registry. In 7, it's stored part of it in XML file and part of it into a registry. And one thing which you might notice is if you have 2 persons on the same laptop, both of them have access to the full list of all the access points you ever connected to. So it's encrypted with DP-API, but in the same time, it's accessible by every user. So now you can ask yourself, well, how you do that? Well, it's not encrypted with your key, it's encrypted with the system key. But the system account has no password. And as I said, we need the SHA-1 of the password to actually decrypt the DP-API. So now you're like, what is my DP-API key exactly? And you scratch your head, and it turns out that it's a LSA secret. So LSA is, again, another container which is encrypted with syskey. If you remember, the syskey is the thing which encrypts the SAM, which should be on a USB key if someone actually ever does that. And it's basically an array of credentials. And inside this, you have, for instance, the help assistant account password. It's here if you want to actually recover it. And you have also the DP-API system, which is actually our key that we are looking for to decrypt Wi-Fi key. So we use that as we use that as a DP-API key. We decrypt the master key, we decrypt the data, and then we have our Wi-Fi. And we thought we can actually extract more information from that, right? We are advocating for cloud services, and one thing we know is a lot of people have laptops, so we say, well, that would be super cool now that we have the key and we have the access point to know where they are. Should be great. And it turned out that there is an app for that. Actually, you have it in Firefox. Mozilla have a nice page about that. It's called the geolocation API, which is used by modern browser to know where you are. So they can actually tell you localized information, and when you ask, they ask for your location, and then you can say, yes, share my locations. That's how it works from the user point of view. Now, how does it work in the backend? Well, behind the curtain, you have this nice little car, you know, this Google, Microsoft car, which are going to do wild driving all across the country and all over the world, and they record MAC address and cell tower position, and they map it with GPS coordinate. And last year, it works perfectly well, and Sami did a talk on that. I did a talk where I show how you can actually extract WPA key from router using SSL injections and then know where the router was. And we say, well, we can integrate this to OWADE. And well, things are never going to be easy, right? So in June, Google said, okay, let's restrict that. So there was a lot of discussion on CNET by Declan, which actually pointed out that this might be bad. And so they say, okay, now you need 2 MAC addresses. well, I have a bunch of MAC addresses I can try, but not reliable. So I say, OK, let's start to see how the other browsers are doing. How, let's say, Internet Explorer is doing it. It's supposed to be HTML5 compliant. How they are doing it? Well, Microsoft used a live service API, which has been documented in the Windows Mobile MSDN. It's a long documentation, but if you just sniff the traffic, you're going to see that it's actually a SOAP request, which is basically a big XML file that you can post to Live, and Live is going to return you the position of the MAC address, and you only needed one MAC address. So we were fine, and we were happy, and we say, OK, now we can actually do it again with OWADE, and I patched, and I was happy. And one thing I did notice is they have like 4 identifiers in this kind of request. One is the application ID. I have no idea what it is. There is a tracking ID, and there is also like the client GUID. And you can actually mess up with all of them. It actually keeps responding to you. I have no idea what they use that for, but it's all over the place here. And so we released that as a blog post because I contacted Microsoft and said it's fine. OK, so I said, OK, let me write a blog post about that. I think it's a pretty cool idea. And then over the night, because it has been posted on CNET, and there was a nice article about that, I had 13,000 people actually go to my page and try the demo online. And I have like now an insane list of MAC address that people try on the page. We get like 50,000 web page overnight, people trying it. And somehow Microsoft realized that something is wrong. And then they send me an email and say, how about we do a phone call tomorrow? And the tomorrow was Saturday in the middle of the afternoon. So Microsoft do work in Saturday afternoon. They even work on Sunday. That's amazing. And so they issue a statement last weekend, and they actually roll out a patch. And well, it doesn't work anymore, so there is a patch for that, I guess. This is Microsoft statement. So now we stand here. Google require you to have at least 2 MAC addresses which are close to each other. And Skyhook require at least to have the MAC address you are querying is actually close to your IP, as far as I can tell. And Microsoft require multiple MAC addresses. I haven't had time to test more deeply, but it seems that all the API does not allow you anymore to geolocalize where your access point was. That being said, if you connect to multiple access points in the same area, you can actually supply both MAC at once, and you might get some hit with that. If you want to see how OWADE displays that, it looks like this. For each access point, we return you the decrypted WPA key, the BSSID, when you did access the access point. So from a corporate point of view, with the tool, you can know if your laptop has ever left the building because you know your own MAC address. So you can actually, by knowing if the user say, my laptop went to the corporate network to my home and only there, you have a way to check that. So it's actually a useful tool in the current state for corporate forensic. Let's discuss a little bit about browser. So Firefox first, because that's my favorite browser. So it stores password in sign-on SQLite, and it uses encryption using DDoS and a master password, which is optional. The reason why they use this, their crypto, is because they actually retake Netscape code, which is the NS library, and they never change it. Hopefully they will. And they store URL in the place.SQLite, which is a SQLite database, and the form field into the form field, which is what you fill in the form history.SQLite. So how you decrypt a Firefox password? It's actually not tied to DP API. You need the user path, which is a master password you might have set only for Firefox. And with that, you're going to have to extract a global salt, which is located into the keytree.db, which is actually a Berkeley DB version 1.8, which I don't know who else used that, which is from the old days. And with that, you're going to do a derivation scheme which involves doing HMAC using SHA1 to derive the key, and then you have the user key. With the user key, you're going to extract from the keytree.db the user encrypted key. You're going to decrypt another key. And the reason why you have this two-pronged decryption is because when you change your master password, they don't want to re-encrypt the entire database. So all they do is they re-encrypt this key with your with your password manager. And with this, then you can decrypt every password and login which are stored into the sign-on.sqlite database. And then you get your password, and from the sign-on database, you extract and you decrypt it. But that's not where the story ends. How many of you are actually shopping at Amazon? No one is shopping at Amazon? Come on, raise your hand. I do. Okay, few people. Okay. So when you shop at Amazon, you have to realize that you have inputted a lot of information about you. You do. For instance, you have inputted, let's say, your name, your address, your phone, and your email. And you have to make this real, because otherwise you will never receive your shiny Kindle. So there is a feature in the browser which is called the form completions, right? Browser helps you to do form complete, and it's turned on by default. Where is this data on the disk? Where is it? Well, it's in the form field, which are recorded, and it's actually recorded in clear, at least for Firefox. And from there, you can get people addresses, you can get people phone number, and so forth. So actually, by doing higher level, you actually get a lot of intel about who is the person the disk belongs to. You can even know where they live. If they ever shop online, there is a huge chance that it's in the form history, as well as all the search ever inputted into the search box from on the right side of Firefox. And let's take another example. I don't know how many of you have a Cisco router. I do have one. Well, you have to configure your WPA key. The WPA key is not a password. It's a plain field. Where is it? Well, it's in the form field again. So by looking at the form field without doing any sort of decryptions, well, you can also recover the WPA key from the router of the person. So actually, form fields contain a lot of private information, and Safari knows that because they actually encrypting it as well. And I'm actually advocating that Firefox do the same. So form history leaks a lot of personal information, and that's a privacy problem for me, at least. Shipping address, Wi-Fi key, credit card informations, and so forth. Amazon doesn't record your credit card information because they say to the browser, do not autocomplete this one. And you can do it as a developer. If you have a website, you can put on-sensitive field autocomplete equal off, and it won't be stored. So you can do it. There is a tag for that, but I think many websites will going to get it wrong, so it doesn't hurt to have this encrypted. How IE works. So IE have a very, very clever way. I have to say IE is clever. Okay. IE have a very clever way to store passwords. They use DP API, and they have a very, very nifty trick, which is they use URL as a salt. So here's how it works. You have the SHA-1 of the URL. So you have to compute the SHA-1 of the signing URL on the website. And you use this with from the URL list. So to compute, to try to crack the, sorry, let me restart. The registry only contains the SHA-1 of the URL. It doesn't contain the URL by itself. It contains the SHA-1 of the URL, and this is where the DP API blob, which contains the login and password, is stored. So we don't know where the DP API password is linked to which URL. So what you have to know is you have to know the URL and use it to actually compute the SHA-1 of the URL. And this is the extra entropy used by IE to encrypt your login and password. Which means that if we do, so when you get the blob, you actually have to know which URL you want to decrypt. So if the user cleans his history and never store anywhere the login, the URL he has used, we have absolutely no way to recover his login and password. It doesn't matter if we have the DP API key, we just don't know how to compute the extra salt. And I think that's a very clever idea to tie the decryption of the login and password to the URL and not store the URL by itself in clear. What we can do is we can try to maximize our recovery process by going through the entire history, form history, and every browser history, and try to extract as much as URL as we can, and then try all of them to try to see if we can actually decrypt some DP API blobs. But if the URL is not in any history, and they did properly handle their, let's say by surfing in private mode, then we have absolutely no guarantee that we're going to decrypt all of them, which I think is very, very good. Chrome, very briefly, they only use DP API. So basically, the credentials are stored into SQLite database, and this SQLite database is encrypted with DP API. And Safari, same thing, encrypted with DP API. They use the Apple format, which is the proprietary list format, which is a binary format, which is their own way to do things. And they use DP API with a fixed string as entropy. The good thing that actually Safari do and no one else do is they actually are encrypting your form field. So the form field are encrypted with DP API with Safari, which is, I think, is the smart things to do. So to wrap up, and I have a sad fox here, which is crying, is I think I never guess I would have had to say that one day, but yes, Internet Explorer is the safest browser for offline. Yes, it's true. I have to say that there is no other way to do that, and I'm also very sad to say Firefox is the worst for offline security. And it has to be patched. There is a bug pending for that for like 2 years, and hopefully they will fix it, I hope. Please, Sid, fix that. He's there in the audience, the guy who does security for Firefox. Please fix that, please. I love Firefox. And they should also make sure to not put the login unencrypted into the login form, because it's encrypted into the form field. So it shouldn't be clear in the other file. That's two things that Firefox needs to patch. A little bit of word about private mode. You know, the thing you use to actually buy a ring to your wife, right? That's or maybe porn mode, I don't know. It turns out that most of the bugs have been fixed since we published a paper last year. One is still remaining. When you connect to the to HTTPS site, Windows has to verify that the certificate is valid by doing a OCSP request, which is basically say to verify, hey, here's my certificate serial number. Is the certificate still valid? This is stored in a different vault than your history. So even when you clear your history, this remains. So we can actually, it's a lot of heavy machine works, because we have to scrap all the serial number in the world, but you can actually use that to know which HTTPS website the user has been, whether it's on private mode or not. It has no impact on that, except Firefox, which actually has its own store, so it's not affected by that. It's for IE mainly. We also have another potential idea how to do that, is basically looking at the Ethernet file and try to extract URL from it. We don't know how good it will be. It's an ongoing work, but we think that's a very important part of OWADE is how to deal with private mode, because it's likely that the most interesting will be done in private mode. OWADE keeps an aggregated view of all the history URL we ever found on the disk, with how many times you have visited them if we know it, and that's how it looks like. So again, OWADE is a web interface, so you just can have a you have a page which says history, and then you see all the page, the URL. Let's discuss a little bit instant messaging software. So the most secure first, Skype. Skype uses custom encryption, and the difficulty, I would write it as extreme, as again, we are not 100% sure we can recover the password. Why? The reason is the way Skype deal with password. What it does is you can extract from DP API a blob, and we know how to decrypt that. That's fairly standard for you by now. And the blob is going to contain an AES key that you're going to compute by using SHA-1 of the content of the DP API blob. And from that, you can actually get the encrypted credentials which are in the config file, and then you think you're done. Well, that's where the problem gets started, which is the credential you decrypt is actually the MD5 of the string, the user login /n Skyper /n the user password. So we know the user Skype username. We can get it from the configuration file, but we don't know its password, so now we have to crack the MD5. So if you choose a very strong password for Skype, well, you are out of luck, because we don't know how to crack it. We have to do a lot of MD5 try, and we have a patch for John for that. So John the Ripper has a patch, and I think it's going to go mainstream in a few weeks. So we have a way to actually try to crack it, but it's a very long password, and we are out of luck. So even if we have all all the heavy machinery behind it, there is some software which are actually secure, again, offline. So we do this password cracking, and as I said, there is a joint patch for that. Google Talk use DP API plus a custom salt. It has been a lot of work to figure out how they actually derive the key. It's stored in the registry. So you start with a string, fix a string, and then you have to get the Windows account name from the SAM, and you're going to mix it. It's basically a XOR. And then when you have that, you have to take the NetBIOS name of the computer. So basically what they try to do is tie as much as they can Google Talk to your machine, and when you have that, you mix it again, and then you take the DP API blob, you decrypt it, you get some data from it, and then you remix it again, and then here you go, you get the credential. That's how you get it. So it's possible. It's completely 100% success, but it's a lot of work to actually come up with the algorithm. But now we know it. It's for you, it's 1 click, 1 second to recover it. Microsoft Messenger. So they keep changing again and again to the point where we have some module we don't even know if they work because we don't even have a Windows Messenger version 7.5. If someone has that, we will be happy to get some data to test. It's not very hard, depending on the versions. The first one was version 5. Microsoft was like just putting them in clear in the registry. Version 6, they say, let's try to use our own API because our own API is good. Let's use a CRUD store. Version 7, someone say, oh no, our own API is not good enough. Let's do something completely different, which is encrypting the salt with DP API and then decrypt the salt and re-put it back to decrypt the second DP API blob. And finally, with the live, probably someone, the product manager, say, no, guys, you should use our own API, so they back to the CRUD store. So the one with CRUD store, we know for sure it works. The version 7.5, I have no idea. We have no data to test. I can't even download the software, so we believe it still works, but we have to test. Now we're going to talk about the other one that some people use, like AMSN. So they decided to use DES, which is simply the 8 first character of your login plus the secret key dummy key. Then you just do a DES key, and then you get your password. No, that's obviously very easy, but it's not the worst. 9talk, which is a French thing, which is basically from SFR now, and we used to be from 9, which was a big provider in France. They do a better encryption than this. They just use XR9. So if you have kids, you can actually show them the password and ask them to do it by hand. It's a nice cryptographic exercise for people. Completely trivial. Trillion, which is like base software which allows you to have multiple accounts for multiple systems. Base 64 encoded, not encrypted, and then XOR with a very, very long string. The long string being the same all the time. Very trivial to do. And we have the winner for our day, which is Pidgin, which doesn't know about encryption. Just put a password into clear in the config file. That's so better. That's so much better. I don't know. I mean, I stopped using Pidgin actually. And then you have this insane guy that I never heard of before, which is PalTalk. So it seems to be popular in some region of the world. You maybe not heard of it, but these guys have like a pretty cool encryption scheme, which is actually worth discussing because of the encryption scheme. What they do is they take the volume serial manager number, so from your disk. So you have to get the disk physically, not the image, and look for it. And then they're going to take your account name and they're going to mix it by doing one character and one another and one another, and they're going to repeat this 3 times. And that's going to be a substitution box. So you take this, then you extract the password from the registry. So it's basically 4 digits separated by space. The 3 first digits are used to for the password encryption. The 4th one, I think, is for timestamp. It just doesn't play any role in encryption, so you remove it. And then you have to do, you take the ASCII code from the key you have derived, and you subtract the YYY. So basically, you take the encrypted characters, and then you have to subtract the part of the S box you just constructed, and actually you have to do it backward. You start with the last part, and you go that way, and you're going to get your password. That's how it works. Pretty strange scheme, worth mentioning because I never seen something like this. My takeaway on Messenger is Skype has, if you have a strong password for Skype, it actually can be broken. We have no idea how to break it. We don't believe it's possible. They have the most robust crypto here. Once again, the trick is do not store the credential directly the credential on the computer. Just store a hash of it. That's the same trick that Microsoft do. I think it's a very nifty trick. We can actually, if you really want to do it, you can actually have a modified version of Skype that actually is going to inject the decrypted credential, so you can log instead of the user, but it only allows you to log in part of the user. You can't actually know what the password was. Gtalk and Paltalk are the only one to use the computer information to try to tie the encryption to the computer. I think it's a good idea, and I think everyone should do it. And if you third-party clients are bad, I mean, mainstream clients do something to protect your data. Open source projects don't. Doesn't seem to be their focus to have security, which I think is a little bit sad. And if you want to see OWADE, we have a module which actually, when you have run all your analysis, is going to have a nice page with all your login and password we extracted from the disk, and we're going to tell you which are the most used password and how many times you use each password, so you can see if people are reusing password and what are the most used email and so forth. So the last part would be, of course, to do up to cloud-based forensic. So the basic idea here is we want to leverage the credential we get to extract data from the cloud. It might be legal, it might be illegal, I have no idea, and I'm not a lawyer, so I'm not going to discuss that with you. If it's not legal, don't do it, please. And currently we only have one probe as a demo. We have a ton of on the way, like a Facebook one, but for now we only have one in the release, which is it goes to LinkedIn, log with the user credential, and going to extract his resume in PDF and all his connection photos and name and so forth, so you know who the guy is connected with. So that's just a demo, but you can probably do it for every services. So how OWADE is currently? What are you going to get if you go to the OWADE page and you want to use it? Well, right now you have to check out the code because it's very unstable. It's alpha stage. We know it works on Ubuntu. So if you have an Ubuntu 10.10 or 10.4, you can run it, you can download it. We have an install file, it's going to work. It only works against XP images. We have to adjust the DPA crypto for working on Windows 7. For some reason, it's not like as simple as changing encryption algorithms. There's something different they are doing. We try to figure out how Microsoft changed things. And our current roadmap for the next upcoming weeks are to stabilize the code, so it works based on people reports. Try to modularize the code so everyone can write their own module, as it's an open source project. It's a GPL3 project. And we have a ton of more cloud probe on the way, extracting emails from every webmail of the world, Facebook cloud probes, and of course maybe Flickr and Picasa. And of course we're working on integrating Windows Vista and 7. As a conclusion, people are moving to the cloud. It doesn't mean that there is, it means that there is more data. It also means that we have to work harder when we do forensic to get them, and it's possible. And now that OWADE is public, it should be easy to integrate this with your own set of tools, or you can use it like as is. And we believe that we have overcome this barrier, which was the encryption of Windows and proprietary software encryption, so you can actually get the data. So now it's up to you and to us to figure out how to use this data, what is legal, what is illegal, how we can actually have nice trick to get more data out of that. And as far as we can tell, OWADE is the first tool which is ever able to decrypt browser data from offline and from Linux. And it's also the first tool which is able to decrypt instant messaging credential. And of course, it's open source. The Black Hat asked us this year, to actually ask you nicely to fill out your form, please. And thanks for attending this talk. And we're going to try to do a demo, which means that I have to switch computer, and hopefully it's going to work. And then we're going to have a question for you. If you want to download OWADE, it's simply owade.org. It's a Bitbucket repository, and we're going to release the code during the day. The slide from this talk and the white paper is already available on the web, on my webpage, so you can get them and feel free to download them if you want. So we're going to try the demo, and then we can answer questions if you want. And it works. Fantastic. So, okay, so here's OWADE, as you can see. So, as I said, Firefox, my favorite browser. So we have Firefox, and this is what OWADE looks like. So here is the main page you get when you have finished your analysis. So we have a lot of information which you can collapse or expand. For instance, you get all the details of what is the user environment before when the disk was run. Like for instance, the system drive was, where is the system drive, where are the profile, and so forth. Let me show you software details. So the computer had Windows Explorer version 8, and more precisely, the display versions. It was running an NVIDIA card because we have the driver 2.7.5.3, which were installed. They were installed in the NVIDIA Corporation directory. You also have Skype here, 5.3, where it has been installed. So you can actually really know from this where what kind of software was installed. And you have a long list, of course. I'm going just to contract everything. And we also have all the environment for each user. Where are the documents for? Where are all the documents for each user? Where are the favorites and so forth? So we get a lot of information that we use after that to know where to extract the Skype data, or where is the Firefox profile, or where is the IE profile. Then we have, of course, what OS you are using. So it was basically Windows XP 5.1 and Service Pack 2, and you have the license info that we can turn back to a serial. I'm not going to show that in the demo. And you have, as I've said, we have the hardware detail about the computer, like what kind of USB stick you ever plug into your computer. So if you look at the screen, you can see that actually I plugged a couple of HP USB disk on my computer, and actually Windows is going to store this for every key you are plugged to the laptop. So from a forensic perspective, it's really interesting because you know if someone has violated the copyright policy and has put a USB stick where they should not have. So it's a very useful thing for forensics in case of confirmations. And you have also what kind of PCI adapter I had, and what is my my CPU, and so forth. So we also have program analysis. So hold on. Okay. So for instance, we're going to take Mathieu account. So Mathieu has Firefox password. There you go, the password which has been stored by Firefox. So the first password was root for OWADE for his own website. The second one was from Google. If you want to have a quick access to the password, we have a short page for that. You click on password, and basically OWADE is just going to display you all the lists in an aggregated view, so you just have a quick look. So from Internet Explorer, we find a password for the domain as hash.fr with the login OWADE, and we have it from Firefox, and we have it from Chrome, and you have Gtalk account here, Trillian account, and you can see all of them in one unified page. And we can tell you which are the most used username and which are the most used address email, so you can do some statistic and analysis and see if people are reusing password or not with a single web page. We also have as a shortcut the history, what the user went to. So it takes a while to load because there's a ton of information. we see that basically this was mainly used by Matthew to work, but you can also see that Matthew is a Steam player here, right? He went to Steam, which is the Valve thing for online, and he also did. He also was reading our the blog post about our geolocation things on CNET, and did a bunch, and even went to Match.fr, which is a dating website, and so forth. So you can actually get a lot of information what people are doing with the history. Of course, it's only for demo. We just call a bunch of URLs just to show you. And in the web analysis, we also have some file statistics, how many music files we found, how many images files we found, and how many different files we found on the hard drive. And to show you the LinkedIn probe we built, we basically download for you the resume of the person. So we have a OWADE user, which is basically, he's a project at Stanford, and he has absolutely no contact because no one wants to be friends with him, but you can have his resume here, directly gathered by OWADE. And of course, OWADE deals with multiple cases, so here we only have one hard drive with one partition, but you can have as much as you want, and then you can do, we hope to build some module which is going to do cross-correlation between cases. And that's pretty much what the demo is about. And now we will be happy to take questions from you guys, and if you want any clarification on any of the module of OWADE, then we'll be happy to answer. Thanks for attending the talk. Yeah. Yes? Okay. So the question is, did we ever look at any third-party manager password such as LastPass? The answer is no, we did not yet. I expect it should be secure, but I don't know. Any other question? Okay. So thanks for attending, and I hope you enjoyed the rest of the Black Hat. And if you have any question or if you have any problem with the software, please let us know. Thanks.